We're going to be looking at multiplying and dividing rational expressions. The first thing is we have to figure out what is a simplified rational expression before we can even get into the multiplication and division part of this. The simplified form of a rational expression is when the numerator and denominator both have a common, or cannot be simplified further and have a common factor of 1. Okay, so when you're looking at that, and when you're talking about a common factor of 1, what that realistically means is you have to factor both the numerator and denominator and cancel anything out that's possible. Okay, so that's going to be the key. Factoring is the key here. In order to simplify a rational expression, in order to multiply, divide, add, subtract, all of that stuff, you have to know how to factor. So if you need to go back and figure out how to factor, I've attached another video as far as how to AC factor. Most of this is going to be quick factoring as far as like the A is the 1 value, but sometimes it's not. So like I said, this is one of those things you're going to have to get really good at factoring. So if I'm looking at the first one. So on the top, actually, let's just do this. I'm going to split this here. We're going to factor each one of them separately, and then we'll combine them together to see what cancels. Okay, so x squared plus 2x plus 1. The quick factorization of that is going to be x plus 1, x plus 1. My green, the first thing I notice is they all have an x in common, so I'm going to factor that one out first. And then from that quadratic, I'm going to factor that if I can, which I can. Okay, so now I'm going to use my factored form. So I have x plus 1 and x plus 1. You could list this as x plus 1 squared. I generally factor it all the way down. And the reason why is because of this situation right here. Only one of the x plus 1s cancel out on the numerator. And so sometimes if I write it as x plus 1 to the power of 2, sometimes students get lost in the fact that they don't understand, I took one of those out, there's still one left. So just one of those things, if you want to list it all the way out, totally fine. If you don't and you understand, totally fine as well. But here I can see that the x plus 1 is going to cancel out. So my final answer is x plus 1 and x over x minus 3. Okay, that's my final answer. Now here's the other thing you have to do, the domain. The domain, this is actually easier just to state what it cannot be, to be totally honest. And this again is kind of based on what we dealt with when we were talking about asymptotes. Now remember, even though I canceled out that x plus 1, that still needs to be stated in my domain because like we saw in Desmos, that actually creates a hole. So there is a difference there. So x cannot equal 0, x cannot equal 3, and x cannot equal -1. That also needs to be a part of it. Moving on to the second one. This again, same concept. I'm going to split this into two separate ideas. Now you might be thinking, okay, on this first top one here, I don't have a common factor. You're right. If you have 4 terms, the strategy you should go for is group factoring. Just like how you kind of AC factor. So I have an x squared and then an x plus 4. Then I look at this set. That's going to be a -1 and an x plus 4. And we've talked about this before, that your parentheses need to be the exact same. If they're not, something's wrong. Now, most people would stop here, but you need to look at the quadratic. When you are looking at your factors. You're trying to get this down so that there is no exponent whatsoever on any x value. That's your goal. Is it always feasible to have that? No, but because you might have some complex stuff and it won't cancel, and that's fine. But you need to consider this one. Okay, so this is going to be x minus 1 and x plus 1. Okay, now let's look at our green. Our green situation, this is going to be a quick factor. We have x plus 4 and x minus 1. So overall, now combine all of that together. Now you might be saying, okay, Fish, but look at this. 2 of these cancel, and we're left with x plus 1. You're right, you are left with that. But in your domain, x cannot equal -4, and x cannot equal 1. Because again, you're going to end up with a hole. Yes, that simplifies down to just a linear equation, but you're still going to have that hole located in at -4 and -1. So very important to remember that, because that's where I see students, they see it cancel and then they look at the domain from what the result was, and that's not actually the case. So that's how you simplify. You need to look at your factors and then see if some things can cancel out. And they'd cancel out because, of course, you know, if you have 3 over 3, that reduces down to a 1. So when you multiply, it's the same concept as far as you're going to try to cancel as much as you can. Okay? Remembering our exponent rules, if you're multiplying the same thing times the same thing, it's going to be, you're going to add those exponents, just as a reminder. When I'm looking at this first one here, I can see that I have a lot that cancels. The y cancels as well as the 2 and the 4, they reduce. So actually, I'm just going to rewrite this as a 1 and a 2. Now, my x's and my z's don't actually cancel there. So I end up with 3x cubed in the numerator and 2z squared. Now it says state the domain. We have 2 different variables here. So not exactly one of those things that you can really kind of state the domain of, but you can state here z cannot equal 0. All right, let's go. I'm going to work left to right. It doesn't really matter, to be quite honest. Now, there's a lot going on here. The key still is to factor. You have to factor. These are all quadratic, so it's a little bit easier as far as, and they're all an x squared with a 1. So we can quick factor most of this. I'm just going to rewrite this. So my middle set there, my middle rational expression can go to be x plus 3 and x minus 2. In the bottom, I have x plus 1, x plus 1. And that last rational expression, I have x and x plus 1. On the bottom there, I know it says 5x minus 10, but you need to factor out a number, because otherwise you might miss the x minus 2 if you don't factor that all the way out. Now, it seems kind of silly to factor out just a number, because most of the time we're thinking that we're going to be able to cancel an expression, but in order to see that expression, you had to factor it. So now comes the fun part, where you get to cancel stuff out. I have an x plus 3, gone. I have an x minus 2, gone. I have an x plus 1, gone. And then the one that people tend to forget, I have a 5, gone. Nothing else can cancel out there. So what do I have left over? I have an x and an x in the numerator, so that ends up being x squared. And then in the denominator, I just have that x plus 1 left over. Stating my domain, regardless of what the final product is, you can't multiply that 5x over x plus 3 if it doesn't exist, okay, if it's not defined, right? So you're going to have x cannot equal -3, x cannot equal -1, and x cannot equal 2. Okay, so you have to go from the factored form on that domain. I cannot stress that enough. All right, part B, once again, have to factor. One of those deals, okay? So in the numerator for my first, on my left expression, I have x plus 4, x minus 4. On that bottom part, I'm going to rewrite this. I'm going to pull out a -1. And the reason why I'm going to do that is because then I am left with x minus 9. I like to have that x first. And if I have that x first and I pull out that -1, it makes it easier to see. Second expression, I have x minus 9, x plus 10. And my third one here, I've got x plus 4 and x plus 10. So I'm going to go through, see what I can cancel. I have an x plus 4, that's gone. X minus 9, gone. X plus 10, gone. Left over, x minus 4 over -1. You could rewrite this if you really want to. Doesn't really matter. I'd take either or. And then our domain, x cannot equal 9, x cannot equal -4, and x cannot equal -10. Final answer. Part D, same exact thing. That's all you're doing. You're just getting that factorization and canceling stuff out. Again, look for your numbers in order to cancel some stuff out. Okay, everything's in factored form. I have an x plus 3, gone. The 3 and the 6 can reduce down to 1 and a 2. And then this is the one that people miss all the time. And that's the x and the x squared. You can cancel this down, but when you cancel that down, that gets rid of that exponent. That's the tricky one. So on the numerator, we're left with x minus 6. On the denominator, I'm going to multiply the 4, the 2, and the 4. So I have 32 times x plus 3. State my domain. X cannot equal 0. X cannot equal -3. Multiply a rational expression by a polynomial. This is the exact same thing. You're going to factor as much as you can, see what can cancel out from there. So I have x squared minus 4, which we know can reduce down further. I'm just going to leave that for right now. On the denominator, let's actually just do this. Let's split this up a little bit. Because this one, we do have to AC factor on this one, so it's not as quick. So x cubed minus 4x goes down to x squared minus 4, x minus 2, x plus 2. Okay, there's my purple. Now let's talk about the green. 6x squared minus 13x minus 5. So as a reminder, how do I AC factor? AC factor You're going to take 6 times 5 to get you 30. You need the factors of 30 that are going to get you to 13. Now you might be saying, well, that could be the 2 and the 15 or the 3 and the 10. You're correct. Because it's a minus 5, it's going to be the 2 and the 15. So 6x squared plus 2x minus 15x minus 5. And then you're group factoring that. So we have 2x, 3x plus 1, minus 5, 3x plus 1. Orange, same thing. You're going to have to AC factor that. Actually, before I AC factor it, I'm going to obviously have to factor out the x. But we're going to do this a little bit at the same time. So looking for the factors of 10 that are going to get me the 3. That's obviously going to be the 2 and the 5. So like I said, you're going to get real good at factoring. Now I've got everything factored down. I'm just going to rewrite this. I have x minus 2, x plus 2. On the green, I have 3x plus 1, 2x minus 5. Then my orange is x plus 1, 2x minus 5. Okay, so when I multiply that, I can see here, I only have one thing that cancels out, and that's the 2x minus 5. Okay, so not a whole lot cancels, and that's just how it goes sometimes. In the numerator, I'm left with x squared, x minus 2, x plus 2, x plus 1. And in the denominator, I'm left with 3x plus 1. Okay, state the domain. X cannot equal negative 1/3, and x cannot equal positive 5 over 2. Just because this video is getting a little bit longer here, I'm not going to do B because I think the idea, the factorization, you're starting to see the idea. So I want to get to the division part. Dividing rational expressions. Find the simplified quotient in the domain. Okay, here's the thing. When you're dividing by a fraction, is realistically multiplication of the reciprocal, aka the flip. Okay, so this is realistically 1 over x squared plus 9x times 3x squared minus 18x over 6 minus x. Okay, that's the equivalency. You're just multiplying by the reciprocal, and then you're doing exactly what we just did above. You're multiplying two rational expressions. You have to factor, and then you have to cancel some stuff out. Okay? So on the bottom there, we get 1 over x plus 9. That second expression, I'm going to factor out a 3x, and then I'm left with x minus 6. In the numerator, I'm going to factor out the negative 1, so I'm left with x minus 6 there. And we look for things that we can cancel. X's are gone, and the x minus 6 is gone. Final result, 3, which I'm just going to put it as the negative on top there, not that it really matters, over x plus 9. Domain, x cannot equal 0, x cannot equal negative 9, and x cannot equal 6. And And guess what? It's the same exact thing here. So you're going to get really good at factoring and figuring out what can cancel. So equivalency here is 2x squared minus 12x over that x plus 5. And you're multiplying by x plus 5 over x minus 6. Okay? So then from there, I go through, I factor. Then we go through and our cancel our stuff out. Now, some of you might ask me, well, if I can see what cancels right away, do I have to show my work on this? The answer is yes, because I want to make sure that you have the factorization correct, first off. And second off, sometimes you might over cancel something, or maybe you misfactored with a plus or a minus and then you canceled it out. I need to see what you actually are trying to cancel. So we're left with 2x, and our domain, x cannot equal negative 5, and x cannot equal positive 6. Okay, so the division is really just the same thing as multiplication. All right, and the last one here. A company is evaluating 2 packaging options for its product line. The more efficient design will have a lesser ratio of surface area to volume. One option is a cube. The other is a rectangular prism with a rectangular base. One side of the base is equal to the side length of the first container, and the other side is twice as long. The surface area of the second container is 4x squared plus 6x. Each, the heights of the 2 containers are equal. Which one has a smaller surface area to volume ratio? Surface area to volume ratio. Okay, so we have to, 1, remember what surface area is. 2, remember volume. And 3, know the formulas for each one of these. Now, the first option is a cube. Okay, if we're talking about a ratio, you want surface area to volume. And then the second one is a rectangular one. So this is just like a box. Again, you still want surface area to volume. Okay, so let's piece out what information we have. One side of the base is equal to the side length of the first container. And the other side is twice as long. The surface area of the second container is this, and the heights of the 2 containers are equal. Okay, so based on that, surface area, remember, is the area of each face added together. For a cube, you have 6 faces of a square, and we know that the height is going to be equal to the other side. We're just going to call that h. So this is 6h squared over volume is going to be, for a cube, is obviously just your side length cubed. Then let's talk about the rectangular one. Side length of the first container, that's the first volume piece. The other side length is twice as long. So if we're talking twice as long, that's 2h. And then the height, again, we labeled as h. So then we have 4x squared plus 6h xh here. So we're going to simplify this down. I'm left with 6 over h here. And on this one, I can't cancel anything out. I can cancel out a 2, I guess. So I have 2x squared plus 3xh over h cubed. So, since we have two different variables there, it's kind of hard because nothing really canceled out in the second one. So your smaller surface area to volume ratio, looking at this, is going to be your cube. And the reason why I say that is because your x isn't going to be a negative number. And if you, it really kind of depends on your x, whatever your x happens to be. But it should be your cube. The goal is that you're just looking at, you're setting up that ratio and you're figuring out the multiplication in order to reduce it. Okay? So this is multiplying and dividing rational expressions. Factoring is the key.